Hey guys, welcome back to the channel. I have another interesting video. Well, it's going to be a test on a FICM 2005, I think it is, because of the part number, because so far I have absolutely no information. This is coming from Texas. David Valencia, this is your FICM. I'm not sure if he or somebody else attempted to repair the FICM. Or, I mean, they were all over the board. But luckily for him or the owner, the module can be repaired. And also, as the normal repairs, I didn't need to do any pre-driver, which will increase exponentially the repair of the module when that part is damaged. So this is what I consider normal repairs. Even though I will definitely have an extra charge in there because, as you will see in the pictures, I mean, this board was they desoldered the coils. There is like almost like a transformers, right? Because it's a high voltage in the board that steps up the voltage for the whole injectors open and close. And they remove them and desolder components and solder all over the connector. I mean, they were, I guess, trying to repair it, but they couldn't. And yeah, those are not normal repairs. So I have to remove all that, solder myself to see what was done under it, because definitely is passages under those coils and under those components that I don't normally need to remove for normal repairs. If I see a burn or something, and then it will not consider normal, and then it will have an extra charge, like in this case for whatever they did in there, right? But at least the board is good. All right, so I'll show you the connections right here. I have my own computer, and I have created a harness with some potentiometers in there to not have the accelerator pedal connector. I also have the VCM because this has an anti-theft system that I have everything ready. And then that is David's FICM. I also, let me show you 1 second. Whoever did the removal was at least careful enough to remove it without damaging the board. The only thing I did see is this cover, what cameras you are, is missing the breather. That is a very important because the breather is a one-way valve. So David, I'm going to change it for one of my covers that I have here that has a breather because those are hard to get. And I can, always reuse the covers when I get the breather back. But I'm going to get you a different cover. So yeah, this one doesn't even have this. Let me show you mine so you can see what I'm talking about. But this part looks in pretty good shape. The cover I have is a very, I mean, it's the same, right? But the breather that I'm talking about is this one. The part numbers are the same. So you can see that this is a Bosch, ends in 7511. And this one ends in 7511. But this one has a sticker from Isuzu and a little bit of a part number or something in there, which doesn't really matter. You can remove that. I mean, all you really need is that part number from Bosch. But yeah, so I'm going to be using this one so I don't have to get you back as soon as possible. And those covers are done. So let me show you the picture first. So you get to see, how that looked when it came. All right, so let me get in display. Yes, you guys are seeing it. See this is the part number 7511. And as you see, this one does not have that metal plate on it. So don't worry about that. It's going to be just because the missing breather, as I said, right? This is how the board came here first. Those capacitors were all removed, and they were removed properly, nothing wrong in that. But we can see, I mean, there were solder here, this solder is in here, solder here. All these are the two transformers, the step transformers that I tell you that they removed. We can see a board damage in here, and then more desoldering and desoldering and all these components, right? So all these components in here were removed, and I'm like, okay, I need to see under it, because if I take that as a good, which I cannot, if I didn't do it, and I know I take pictures and everything is good, how do I know it's good? So yes, in order for me to repair something, I'm not just going to start doing my normal repairs and assuming that is good, because it will come and hunt me, and then I have to remove and install. No, so I actually remove all that, solder everything myself, check, make sure the board was fine, and then proceed with my normal repairs. The other side of the board, I did take a picture as well. And we can see here that, again, whoever did the removal, it didn't do it bad. I cleaned the entire board. It was very careful removing, so we can see the sticker. This is a thermal, almost like a thermal tape that will be in there, so the drivers don't short in the case, because that's where the injector drivers are, and it's going to create a lot of heat. So the manufacturer of this board put that extra layer of protection, so it will never be a chance of shorting out, because all you need is to transfer the temperature from those components over to the aluminum case, and that will dissipate everything. But as you can see here, I mean, let me just get a little bit of a zoom. I don't know if they removed the entire connector for a reason, or just resoldered every single pin. I clean and I inspect the solders. Were a couple of solders that I needed to retouch. Not a bad solder, let's say. So I cannot say anything that was done wrong. But like I said, when I see a component that has been touched on this match, and it comes to me, it's not considered a normal repair. So normal repair is if you open the board and you send me a picture and says, Mike, yes, this board is it's not burned. Can you repair it? Okay, let me see the picture. Yes, send it over. That can be repaired. And then I do the same thing that I'm doing here. As I have explained in multiple of my videos, I used to test and then do the normal repairs. But then I thought about myself, because I did that one in one. And when I removed the capacitors, they were about to explode, and they literally will explode. Especially those big ones, they will sound like almost like a bullet exploding, or like a firecracker. And think about, this is a small room and all my components. This will smoke out everything, and it can hurt me. So I removed myself from that, and I said, you know what? No, I'm going to perform unless it's burned, obviously. If it's not burned, I do the normal repairs first, then do the test. If the component works and there is, air or injector on both banks, you're good to go. It's normal repairs. But if I do the normal repairs and it goes into turning off a bank or both bank of injectors, then is the next step up, which is the pre-driver, which is, I said in multiple of my videos, that will exponentially increase the cost of the repair, not because I want to. Is that component itself. It's only one supplier that I know has it, and it's charging almost $700 for one electronic component, and that is just ridiculous. But it's not for me. I just install it, and that's all I can do. But yeah, so let's go back to this test now that you saw the board, right? Right. So now I have everything nice and clean. I still have not put, I will put, a special glue or rubberized silicone in between the capacitors to absorb vibration, because this is sitting on top of the valve cover. All right. So I'm going to put the simulator that I'm using for this is the full probe. Then I'm going to have the SUS just to erase faults in case the anti-theft goes on, because sometimes it does when I'm cycling the key on and off. And then the picoscope, which is the main and most important view right there. That's the last one I just added in there. That's an oscilloscope, which is going to show us the amplitude and the voltage. I put two measurements of the maximum on the blue channel and on the red channel. So one bank, I have two channels. Blue is onto bank on this side, and then on the other side, I forgot, which side is which on here, but it doesn't matter. So we have the blue channel for this side, and then the red channel on one of the injectors per side, and then we can go from there. All right, so let me get into the full probe, which I think is ready to go. And let me just put some RPMs. You see, it's like as soon as I cycle the ignition, I'm gonna have to kill this one more time, put the ignition on, and then I'm going to have to go over to the scanner to erase the fault because it went into anti-theft. Go back. Oh, too much. like transmission, clear codes. And let me display the codes to make sure that we don't have, doesn't matter. Yeah, we don't have anything as far as codes and not in history as well. Perfect. That's all I really need to do. So let's try to run it again. Make sure that works. Sometimes I have to kill the power completely. Nope, it worked. All right, so right there, you can see now both bank of injectors working. And this is good because if it would be any shutdown on a bank, then I will have to replace that pre-driver that I was talking about. And right now we can see both bank of injectors working almost evenly, right? So we can see the blue channel with like a 50 volts and the red channel with like 49 volts. But the most important thing is the signature of that waveform. So I can stop the capture and we're going to analyze just shortly that so you can see and understand how those signals look when they're operating. So you can see right now both of those signals having like a I don't know, like a blue or red area. There is kind of like fill. So if I zoom closer, you're going to see that is actually an oscillating area. That's where the computer driver is turning on and then goes out and then pulse width modulate that signal to keep that injector open. That is exactly the signature. That's how it's called, that waveform like that is like a signature, like your own signature, right? That's what we call, that is the signature for the injector, for a good working injector. And if we go over to the other injector, let me go back. If we go over to the blue channel, which should be pretty close here, am I going to have to go back one more time? Yeah, let's do a zoom, and that we can do that better. We can see how the blue channel itself is also looking very nice, and we have the same look, and it's working good. So I'm going to keep it running. Let me take the zoom away, but we can see the activations. On the bottom, you can see 50 volts and 50 volts. So this is working beautiful. So right now we have a nice working FICM. So David, this is a full repair. So this is a good now a good FICM. Luckily for whoever touched this, it's working good. I'm going to increase the RPM so we can see more activations on the screen. I'm in 2300 RPMs. Everything is working good. I'm going to come down to idle one more time. That is 850. So we can see the FICM and both bank working great. So that is, if it would be a problem on this FICM right now with any of the injector drivers, it would shut that bank down. Then you get the P2195 or the P2194. Let me make sure I'm giving you those fault codes correctly. I have all that information here. So give me 1 second. Wiring, data sheets, test. I'm looking for the fault codes. False. Where are the faults? But I have it. Give me 1 second, guys, to find that out. I got it quickly, actually. So let me move you over to the screen. What I have it, I'm going to take the Pico out, which I really would like to keep it because you guys can see, but let's just do this just pretty quickly so you can see the fault codes. So P1293 or P1295, that is also a bank of injectors shutdown. You got the P1294, P1296. All those fault codes can affect the firing of the injector. So I was saying actually the number wrong. It's spelled P1293, P1295. You got the 94. It says circuit low, bank 1, bank 2. Yeah, the 1293 and the 1295 is for bank 1 or P1294 or P1296 for bank 2. Then you can have a specific injector's fault, which are different, but that will be in a specific injector fault code. Well, let me go back to here to make sure that we can get that picoscope and you can see both signals in there. I'm going to increase the idle one more time. We can see more activations in there. That's exactly what we're looking. I'm like almost in 3,000 right there. I'm going to go back to idle. I'm in 650 now. That's a little too low for diesel, 950. And I put no trigger. The trigger will stop the signal because I want you to see that signal happen in live, like no stops, no nothing. But you can see how the voltage, which is those measurements that I have at the bottom of the speaker scope, are both working good. All right, so David, I will contact you shortly as soon as well, I got your text message, but I got no big number, no concerns, no absolutely nothing, not even a return address. The address on the package was a UPS store. So right now I got a good FICM, but I got no way to send the bill to the customer or even a return address. So please, when you send a module, let me stop this 1 second so I can talk with less noise, at least for myself in here. Please, when you send a module, I always encourage my customers to please go over to my website, which I'm going to show you just briefly again. And if you're here and you have not subscribed to the channel, please subscribe to my channel. That helps my small business a lot. Every time you subscribe, YouTube promotes more and more my videos, and that's how you find me here. And it's also for free. So if you do so, thank you so much. Okay, so if you have any computers, instrument cluster, automotive, or marine that you need to send to repairs, this is my website. Just look for MikeSalazarDiagnostics.com. My name is spelled different, but sounds as Mike. And then in here, you can click on that white box right under the big letters in the center of the screen that says Mike Salazar Diagnostics. You have the address in the middle, and then two boxes on either side. The white one is clickable, and the black one, if you click in the white one, that will download a Word document with all the information I need from you. That's a repair form, and I need you to sign so you are approving me to test your module. I will give you an estimate and then send you through the emails and everything. Then that's the main reason I need to have an email, because I texted David 2 hours ago and he hasn't even responded. So this is where an email or different ways to communicate is the best. So because sometimes you are in a meeting or something that you cannot answer on a text message or see a text message or a call, but an email you can. So I'm always trying to get as much as ways of contact you like that I can keep moving. I already had an approval by, voice approval, let's say, on a text with David about repairing this, and that's what the reason is in here. But I definitely need to have a full open access to contact you in case you have something in here. Again, just navigate my website. This is a full website. I have a forum. I got members. I got reviews. Thank you. If you have anything that needs to be repaired, please contact me. You will be in the best hands, no doubt about it. There is no other companies that does what I do as far as recording a video, keeping you up to date. Go on Google and look for Mike Salazar Diagnostics reviews, and you will see what I'm talking about. I got only happy customers because I try to go even beyond normal customer service, keep you up to date on the whole process, pictures, videos. Why? Because I do think that trust is the most important thing in between two parties, and also transparency. And that is what I do this. With transparency, you trust me. Why? Because I am a full transparent business. I got nothing to hide. I know what I'm doing. You're in the best hands. All right. See you next time. Bye-bye.